For 12D, we're given that a right triangle with a hypotenuse of 30 feet as it has its base, increasing at a rate of 5 feet per second. Find the rate that the height is decreasing when the base is 18 feet. So for this, we have a right triangle like this, and I'm just going to call it X, Y, and Z right here. So we have that. And of course, the Pythagorean theorem is going to be the formula that you're going to be using on this one here. Now, now we have the variables that are set up. It says that a right triangle with a hypotenuse of 30. Okay, so if a hypotenuse is always 30, we don't need to put another variable there for that one. What we can do, now you can go ahead and write it like this and take the derivative, but then that would just mean that your z is never changing, so you have to know to put a 0 in there on that side. It's going to be easier if you go ahead and just put a 30 in there right away, and that way we can just put 30 squared right here, and it's automatically going to turn into a 0 when you take the derivative. So it's probably better if you see one side on here that's never changing, you want to go ahead and put that one in. You're not necessarily going to have variables for all the sides in this case. So that's always 30, never changing. So we just have x and y to deal with here. So it says that the base is increasing at a rate of 5 feet per second. That's the x that we called here. So that's going to be our dx dt. That's equal to 5 feet per second. So 5 feet per second here. All right, now next it says find the rate the height is decreasing. Now, because it says find the rate at which the height is decreasing, that means that this should end up being a negative number when I find it. So negative means that that number would be going down or decreasing. So I should expect my answer to be negative here. Find the rate the height is decreasing when the base is 18 feet. So the base, it's got to be 18 right there. X is 18. Now here's our formula. Let's go ahead and take the derivative of both sides with respect to time. You're going to get 2x dx dt plus 2y dy dt. And then that's a constant on the right-hand side. It's going to be a 0. From here, let's put in the information that's provided. We have 2. The x is going to be 18. dx dt was given here as 5. Next we have 2. Now the y is not given here, but we can go back and use this formula to solve for the y. So we're going to do 18 squared plus y squared equals 30 squared. Like that. So if you go through all that and solve, let's go ahead and give you the answer there. The y is equal to 24 when you solve that one. So now we know that this is going to be 24 in here, and dy dt is the only one that's left that has to equal 0. So now we're going to multiply all this out here. So what's going to happen is this part there is going to be 180. So 180 plus 48 dy dt is equal to 0. Now we have to come up here and solve for the rest of it. We're going to do 48 dy dt is equal to negative 180. So now we're going to divide both sides by 48. dy dt equals negative 180 divided by 48. So as a fraction, you can reduce it, or if you turn it into a decimal, it's negative 3.75. That's going to be feet per second, because that was the same unit of measurement that the x was changing in, so the y will be changing in the same rate. So that would be the units on that one, feet per second.